Hello everyone. So I want to post a video in the description below, a little short clip of a 3D metal printer on the International Space Station that just did its first demo. Super cool. So my name is Laura Forsick. I'm the executive director of space consulting firm Astrolytical. I've been in the space industry for 20 years, and this caught my eye because it's just the first step towards manufacturing in space. Or maybe not the first step, maybe like the second step or the third step, depending on how you want to look at this. So if you think back to 3D printing in space, we've had a few examples from Redwire. Made in Space is the company that was bought by Redwire. They had the first 3D printers on the International Space Station. And they printed things like plastic and most recently biocells, cardiac cells, which I am not enough of a life scientist. I'm not a life scientist, I'm a physical scientist, but I'm not a life scientist. So I was reading up on it, trying to understand cardiac cells 3D printed in space. That was a recent thing from this year, by the way. So go look that up. That's awesome. But the reason why metal 3D printing in space excites me because what it can become. So this was a video posted today by ESA. Again, I'll have the link in the description below. ESA is the European Space Agency. They launched this 3D printer in January. It was put together by Airbus. So it's an Airbus printer. I'm trying to see. It's just called Metal 3D Printer is what it's literally called. And they did the first demo. They actually did it on Thursday last week, but they just posted the video today. And they just have these little S's. That's all. So they just 3D printed some S's. So it doesn't look very impressive, but think of what that can do. Think about all the ways that we can do, any kind of manufacturing in space, starting with small scale, right? Now, I'm not necessarily a believer of someone who thinks that we're going to have a mass manufacturing in space anytime soon. I say this, but I used to work at ISS National Lab. So there's an organization called CASIS that runs the International Space Station National Laboratory for the United States. And I was the first physical scientist that they had on the team to look at different scientific, payloads that could fly on the International Space Station for the benefit of life on Earth. And so we did look at these kinds of things. And the idea is that we want to understand how, and by the way, there was no way I could do this recording today without the baby right next to me. So that's what that sound is. I might have to pick him up in a moment. Flying these experiments in space. So it was like the very beginning of 3D printing back then. I guess 3D printing's been around for a few decades now, but it was super early on. It was called like rapid prototyping back then. And we looked at some of this and we were trying to understand, there's the concept of manufacturing drugs in space or manufacturing, fiber optic cables or wires in space, and just all these ways that we can maybe take process that we do on Earth to manufacture something and make it better by manufacturing it in space where there's net zero gravity and the lack of impurities, the lack of bubbles, or the more roundness of the sphere, or whatever it happens to be. And that technology or that concept is still very new. Even though it's been tested now for several decades on ISS and previous space stations before it, it's still in its infancy. It has not proven itself. So I don't think necessarily that we're going to go and 3D print metal objects to then sell to Earth. Like, I really don't see that happening anytime soon. What excites me is the idea of ISAM, or OSAM if you're older. ISAM is in space. I can't believe I always mess up this acronym every single time. In space, servicing, assembly, and manufacturing. Or if you remember OSAM, on orbit, servicing, assembly, and manufacturing. Specifically the manufacturing side, of course, servicing, you're going to want to need the 3D printing too if you're going to be if you're going to be doing something that needs to be serviced, that needs like another part, then that ties in. But for me, the exciting part is the manufacturing. Think about how long it took to put together the International Space Station. It took, it's technically not even done, even though I think we're calling it done. But there were ideas of modules to add to ISS that, it's been 2 decades. It's been more than 2 decades, actually, since the ISS has had its first launch of its first module. And the idea is that if you are able to do stuff like 3D print in space, starting with small scale, yes, but then getting to larger scale. If we are taking stuff from Earth and putting it in space, and then it lives out its lifetime, and then what? We're just going to deorbit it? And I actually have a video recently where I talked about deorbiting versus recycling or repurposing in space. What if we get to the point where we can take the material, the metal, from whatever object is in space that is no longer serving a purpose, And instead of deorbiting the whole thing, just burning it up in the atmosphere, we can take that metal and recycle it, put it, melt it back down. And there is a company that is doing just that. And then the idea is that maybe we can take that metal and like reuse that metal, 3D print it. I think that's brilliant. If we can get that technology, of course, the technology is super, super early, right? They just did that demonstration Thursday last week of the first 3D printed S's in space. But if we can get to the point where we are actually 3D printing in space, imagine what we can build. Imagine the structures we can build. Current technology seems to be moving in the direction of inflatables. So there are several companies that are doing inflatable habitats. Think back to the Bigelow Aerospace days. There is actually still a module on the International Space Station that's an inflatable module that was inflated by Bigelow. It's a Bigelow module that they use it for storage. And there are a number of different private space station, commercial space station, or a new space station like Gateway designs where they are using either traditional methods of manufacturing or thinking ahead to like how you can expand things in space using these inflatable technologies. And then if you think about it, what if we just 3D print in space? Whether we 3D print the entire structure, 3D print part of the structure, 3D print things that connect together, even just like if you lose a tool in space, which happens, it's unfortunate, but it happens. If you're doing an EVA and you lose the tool in space, 3D print another one. Like, especially if plastic isn't going to work, maybe it needs to be metal, maybe it's a bolt, or maybe it's, whatever it happens to be, that can really not only help us with the manufacturing of these kinds of facilities, but maybe the kind of research we want to do. Or maybe it's some other kind of engineering structure. Maybe it's 3D printing replacement parts for a space observatory, or, getting to the point where we are further out in space and we can't reasonably go and get stuff from Earth. Maybe we're beyond Mars and we just haven't developed that technology. He's talking along. Anyway, I'll make this short. Anyway, this whole concept here that was announced today by ESA of 3D printing metal in space, I find it so exciting because of the possibilities. We are still very early, but I really do think this is an area of growth once we get the technology more streamlined and really can prove it out a little bit more. Not just with this ESA printer, this Airbus printer, but also with larger printers and, thinking ahead to future space stations and the capabilities that those future space stations might have. I told myself I wanted to make a video a day talking about the news and giving insights on the news, but and it's finding to be much more difficult to do that during a weekday. So thank you all for bearing with me. If you want more insights in space news with or without a baby in arms, please go ahead and subscribe and get this in your feed. Thanks so much.